how you prove the sign, the derivative of the sign. We're going through it step by step. The only thing that would be tricky for us is the identity, but it's in your notes. And then a lot of it is just algebra. Okay? So how are we so far? Well, now we can start evaluating some of these limits. And let's start with this one. Let me ask you this. What is the limit as, I'm going to change this problem to this. What's the limit as x approaches 0 of sine x? What's this limit equal to? How did you figure that out? You plug in 0 for x. Yeah, it's a continuous function. Since it's continuous, the limit value equals the function value. Okay? So this equals 0. What is this equal to? Limit as x approaches 0 of 5. Where did you plug it in? It's a constant. It's always equal to 5. Does that make sense? What's the limit as h approaches 0 of sine x? Why? Plug the h in. You can, just like you can here. You know what I'm saying? And stuff like that, this technical, like where do you plug it in? Sure, you can plug this in. You plug it into nothing, so that's equal to sine x. Does that make sense, you guys? The limit is h approaches 0 of sine x. Sure, plug the h in. Where do you plug it in? Nowhere. Limit as x approaches 0 of 5. Sure, plug it in. Where do you plug it in? Nowhere. 5. You see the difference, you guys? Okay, now this is one we did on our calculator. I want you guys to do it again right now. Now see, this is an h, and then this is an h, and this is an h. So I want you to treat this as limit as x approaches 0 of cos x minus 1 over x, but graph it. I want you to graph cos x minus 1 over x. Make sure you're still in radians. Does anyone remember what this one is? It is 0. Just verify that for me in radians. So you should be doing that now. Graph cos x minus 1 over x in radians. We're going to keep it in radians for a little bit, and then we're going to switch. And just see what you get. Make sure that whole cos x minus 1 over x is in parentheses. And what's the limit? Yeah, the limit is 0. You can check in your table, you can do all of that. That limit, the limit as h approaches 0, cos h minus 1 over h is equal to 0 plus, what's the limit as h approaches 0 of cos x? Does that make sense, you guys? How are we feeling with this, Amina? Yes, I will. The limit as h approaches 0 of cos x is what? Yeah. Times. Okay, check this one out. What's the limit as x approaches 0 of sine x over x? This is one we've done. If you don't remember, graph it. It is 1. And that one, know that one. The limit as x approaches 0 of sine x over x is 1. So what's the limit as h approaches 0 of sine h over h? Yeah, see how they're all the same? It's all a variable, they're all the same. You know what I'm saying? So this is also equal to 1. And verify it on your graph. Do you guys have it? Yeah? Wait a minute, did you graph sine x over x just to verify it? Do it right now. Everyone graph sine x over x, and I want the limit as x approaches 0. There you go. You remember that one? Okay. So is that equal to 1 e's? Okay. So we did all of this work. And now we just evaluated all the limits. We're able to evaluate all 4 of these limits. And what do we get? This is cosine of x. What is this the answer to? What was the goal of this whole problem? Right. And that's what happens, all of that definition of the derivative. We get in it and we start doing all this stuff. What did we begin doing? Finding the derivative of the sine function using the difference quotient. And we got cosine. You just proved that the derivative of sine is cosine. Doing it the algebraic, that is the formal proof. Okay? Kudos to you guys. Now, your calculators were in radians, right? Yes? Did everyone verify your calculators were in radians?
Yeah.
Did you show your partner, hey look, partner Joe, I'm in radians? Because now I want you to do this, because Sonia asked a very good question. What happens in degrees? Well, evaluate this limit now, because it should be the same. There's no, who cares? You know, like this is just, there was no trickery or tomfoolery. All of this stuff was just algebra, right? So it should work, right? The only thing we looked at as far as in radians were these two things right here. These are the same. So let's take a look at sine x over x in degrees. And I want to know what that limit equals.
Why, if you have sine x, and that's in radians, and you're trying to find it in degrees, why would you not touch on sine x, but instead touch on the h's?
What I'm saying is like this is still this. Oh, this is still sine x because the limit is h approaches 0. That's not going to change.
Okay.
Whatever this sine x is, that's not changing. Whatever this is isn't changing. I'm saying the only thing we looked at a graph on in radian mode was this and this.
But I thought h was the number. H was like that tiny, tiny number.
It is. So what I'm saying is like we looked at these graphs in radian mode. That's how you got these numbers. So what I want you to do is get these numbers in degree mode. You just see what the difference, if there's any difference. Because this is what we looked at a graph of, in radian mode. We needed radian mode to get this one. I want to know in degree mode. And just, is there any difference? Maybe there's not. Maybe it's all good. What'd you guys get? So the only thing I'm going to hit, I have y equals sine x over x. I'm going to change my mode to degrees. And what? It disappeared. Does that mean it doesn't exist at all? Well, yeah, if you're not sure what I do, Marco, just check your table. Oh, I got values. Oh, and I have little... Oh, shoot. Well, I'll tell you what. Let me do this. I changed this already. I have these values here. You see it? What the heck is 0.01745? That's the number. Okay, that's what it is. Well, it is what it is. Like, does sine x over x make sense? I don't know, like, but that's what sine x over x was 1 in radian mode, but now it's 0.01745. Okay? Well, check this one. What's cos x minus 1 over x in degree mode? Check it. Check your graph. See what that limit is. Now this is in degrees. Now we're doing this whole problem in degrees. This thing changed. Check this limit now again. Go back and do this one again. And what's that limit value equal to? In degree mode. That one doesn't change? Do we got any confirmation that this stayed 0? Yes, I have 2 people and I have a third. Oh, we have a 4th now. Okay, so this is still 0. So now we're left with this. So this is gone. So the derivative of sine in degree mode is equal to 0.01745 cos x. The derivative of the sine in degree mode is equal to this. Okay, I guess put it in our notes. We're in degree mode. Let's keep that 0.017.